Hello, Caitlin, Alex, and JD. This is Geometry 1.2 using segments and congruence. So this is a new term for you. A lot of people like to say that this is equal, but you've got to be careful. So I will try to distinguish that a little bit later. Our learning targets, I can apply the ruler postulate, I can apply the segment addition postulate, and I can compare segments for congruence. I do believe after this section you're going to kind of feel that these are obvious, but let's move on. Here we go. First of all, with the warm-up, we will be solving equations. I think there's a little glare. I wonder if I can turn that off. That might be better. All right, so here we go. Let's combine like terms. 3x plus 2x is 5x. 5 plus a negative 4 is 1 equals 36. And now let's subtract 1 on both sides. 5x is equal to 35. Naturally, I don't have enough space here. Divide both sides by 5. X equals 7. Okay, let's see here. Find 3 cities on this map that appear to be linear. Of course, we can use the word collinear, but it says appear. So I'm just going to use this straight edge. I guess I'll use this one. If you look, let's see here. It almost seems like these 3 dots right here are linear. So it could be Rockford, Bloomington, and Cairo. But the one that popped out right away for me were these 3. I really don't know how much to scale that this is, but you have 2 options here. Chicago, Bloomington, and Springfield. Alright, so those seem to be in straight lines. Actually, they look pretty good. Alright, here we go. The ruler postulate. Okay, the ruler postulate. Points on the line can be matched 1-to-1 with real numbers. Alright, so basically you can assign like distances. Can you actually see those? This is a centimeter ruler. It looks like it's about 2.5 centimeters apart, but you can apply numbers. And if you can apply numbers, that means you can also find the distance. And this notation, the absolute value, you're finding the distance between one point and another, so you'll just subtract them. X sub 1, small numbers are called subscripts, and it's read x sub 1. So the absolute value of x sub 2 minus x sub 1. So that's the distance between those two. There's your ruler postulate. You're just finding the distance. All right, so measure the length of AB. So I have my little ruler here, and I think the light would be better if this was on. Yeah. So AB is about 2 centimeters, because they went to the nearest centimeter. And then measure the BC. BC is about 4 centimeters. How long is AC? 6. Okay, so that's going to come up. Now notice I didn't put the segment above AC, because as soon as you apply a number, a measurement, it's now like a distance. All right, next page. Segment addition postulate. All right, here it is. I kind of led you to it with the last example. If C is between A and B, that means AC plus CB equals AB. So C here is between A and B. You're going to take this part plus this part will equal the whole thing. So using a little algebra into our geometry, AC is x, CB is 2x, the whole thing is equal to 12. Combine them and solve. So let's do an example. I am trying to rush this a little bit because the last video was 14 minutes long, so I do apologize. Find AB. AB is x plus 4, BC is 4, and the whole length is 3x plus 2. So x plus 4 is equal to 3x plus 2. Combine like terms. X plus 8 equals 3x plus 2. I need to get x's on one side, numbers on the other, so I'm going to subtract that smaller x over. 8 is equal to 2x minus 2. I want to add 2 to both sides. 2x is equal to 10. Divide by 2. X is equal to 5. So remember, a lot of people stop right there, but they don't actually answer the question. The question says find AB. If x is 5, 5 plus 4 is equal to 9. on, do I have an error here? Oh, right, I do. Look at this. For some reason I put +2 and I have a -2. So we're going to add 2. So then we're going to subtract. Do you know how I knew I had an error? I looked at my notes that I did earlier. 6 divided by 2 will be 3. 3 plus 4 is equal to 7. Yeah, see, I always have notes. All right, so now let's try this one. Hopefully I can do it without error. 8 plus x plus 12 is equal to 2x plus 20. Combine like terms. X plus 12 equals 2x, whoops, x plus 20 equals 2x plus 20. And let's subtract that smaller x over. You might be thinking something weird is going to be happening. We have x plus 20, and I'm going to subtract 20. What happens? X equals 0. Well, that can happen. So here, x is 0. So what's the length of dB? You have 8 plus 12 equals 20. Or if you plug 0 here, you get 20. So it still works. All right, let's do example 3. 15 plus 20 plus x equals 54. Combine like terms. 35 plus x equals 54. Subtract 35 on both sides. X is equal to 19. And they wanted CD. I should emphasize that. Make sure you always read the directions. Next page. See, yeah, I told you this is going to be easy. Congruent segments. Okay, now this is where all your symbols are really important. So I'm going to take out that pink pen also. Segments with equal lengths. The congruent symbol. It's a big equal sign with a wave on top. Okay? This is congruent. If you're too lazy to write congruent, you just make that symbol. Versus this is similar. I've used that in the past. Okay. Congruent segments are marked with dashes. For instance, if you had a rectangle, this segment is congruent to that one. This segment is congruent to that one. Notice I put 2 dashes on these two because you can't put 1. That means they would all be the same length and it would be a square. This is a rectangle. All right, so if the numbers are equal, the objects are congruent. Now, one thing I want you to notice, correct notation. Once you remove that segment line, the measures are equal. There's an equal sign in there. I don't know if you could see that. But the segments themselves are congruent. So you want to use the congruent symbol for the segments. Put an equal sign for the measurements. All right. Plot these 4 points. -2, -5. Label that x. -2, 3. Label that y. -4, 3. We're going to label that w. And 4, 3, we're going to label that z. So they want to know on the coordinate plane are xy, this segment, congruent to wz, this segment. Well, let's find the length. So wz is equal to 1, 2, 3, 4, 5, 6, 7, 8. And xy is equal to 1, 2, 3, 4, oops, I miscount. 1, 2, 3, 4, 5, 6, 7, 8 is equal to 8. Ah, they're the same measurement. So I'm going to write wz is equal to xy equal to 8. Or you'll say wz, with a segment over it, is congruent to xy with a segment over it. So if their measures are the same, the segments are congruent. Here's your homework assignment, and here are your standards. Have a nice afternoon.